Good evening, everyone. Can someone confirm if I'm audible?
Audible, ma'am?
Okay, thank you. Yes, so we'll just wait for a few more minutes and wait for everybody to join in because this is the first session and then we'll start from there.
Ma'am, your slides are not visible.
I'm sharing that.
Ma'am, please help me. I'm having only tablet. So how to use that MATLAB on tablet, ma'am?
About MATLAB on tablet. Am I audible?
Yes, ma'am.
Okay, great. Yeah, so MATLAB on tablet, I'm not sure. What is the OS that you have over there?
Normally, these tablets they use uh, Android.
Hmm. I'm not sure if MATLAB would be supported there, but try on a workstation or a laptop, maybe that will be helpful. Or probably MATLAB also offers an online version. I can maybe check that
Yes,
towards
ma'am.
the end of
Online
the
version is
session and
there.
then
So
share. Mhm.
yes, ma'am. Online version is there. So please guide me so that uh, because for this course, okay, then we have to take laptop.
Okay, sure, sure. We'll check that towards the end of the session.
Just show ma'am how to use MATLAB, that online MATLAB, so that we can use online. That can be possible.
Okay, okay. I'll take a tutorial on that. Okay, I guess number of people have saturated. So let's get started. Welcome everyone to the first TA session of this course, Foundations of Cyber Physical Systems. And yeah, so this is basically the TA session offered by these PMRF students. So I'm from IISc Bangalore and I'm pursuing my PhD here. So I'm doing this TA-ship as a part of my PMRF program. Okay, so I would first share the format of the sessions that we will be having over the next 12 weeks. Um, so it is suggested that you should go through the week lecture recordings before coming to these sessions so that you can ask questions and clarify all your doubts that you have. And eventually, these sessions should help you in working on your assignments and help clarify any doubt that you have. Okay. I think the week recordings are uploaded by Monday every week. So you should go through that. And then I'll be solving some questions that will help you solve this week's assignment. So every week they will be releasing an assignment, and every week I'll be helping you to solve those assignment. I won't be technically solving those questions, but just giving you hints or trying to solve, like similar kind of questions that eventually help you. And if you want me to cover some selected topics from the current week recordings, please feel free to do that. So that also I can cover depending on the time. And discussion on doubt from the previous week assignment. So let's say this is week one, and once the assignment deadline has passed and you have finished everything, and let's say they gave you some answer which you are not very sure of, and you still have some doubt as to how that answer came, but and you want to learn that, for the course, and uh, keep that in mind till your final exam. So please do that also. So we will be meeting 6 p.m. to 8 p.m. every Saturday, unless there is some other announcement based on if something happens at my end and I have to reschedule. But otherwise, every lecture is going to be recorded, and the YouTube link for each of the lecture will be provided in the log sheet. I think that will be shared with all of you. And this will also have the materials that I am going through right now. So whatever I'm presenting, I'll be uploading that as a PDF to that particular drive link that I'll be sharing in the log sheet. Okay, so this is what is the mode of teaching. So yeah, in general, you follow the lectures, come for this problem discussion, the doubt discussion on the selected topics, and I think you should be good for this course. Okay, and other than that, since we are interfacing using Microsoft Teams, so I have enabled the chat window for everybody, and I will be having a look at that also during the lectures. So feel free to type in your doubts over there, and I will be taking that whenever I can, even in the middle of the lectures. And if you want to ask any questions by, unmuting yourself, then please raise your hand so that I know that you want to ask a question, and then you can go ahead and ask the question. Okay, any doubts up to here?
Ma'am, we received two emails. One email wherein it was told that the lecture is from 3 to 5. And then
Correct.
second email, we got that lecture is from 6 to 8 now, which is happening.
Okay.
So, what will be the time for next 12, what you say, weeks? 3 to
Yeah,
5 or
so
6 to 8?
So basically, as I said, right, these TA ships are for PMRF students. So this course has two TAs. Okay, so one TA session happens 3 to 5, as you said, and the other one happens 6 to 8. So my session will happen every Saturday, 6 to 8 only. The other timing is for the other TA. So you can join either of these depending on your availability.
Hey, that first session was not there. I logged in twice, but nobody was there.
Oh, then I'm not sure because, yeah, I'm not sure about that. Okay, any other
And
questions?
Ma'am,
Mhm.
both the TS, the topic will be same. So that suppose if today I am busy from 6 to 8, so
Right.
if so I want to attend that what you say 3 to 5. But today because that had not happened, the
Mhm.
question both sessions cover the same or they may be different.
The topics that the other TA covers will be similar because we are supposed to cover topics which are covered in the lectures, right? So they won't be very different. It's more about the content of the like session. So it just depends, like depending on what method they use, and depending on what they want to cover in the content of the week, things may differ a little bit, but overall it will be the same. Does that answer your question?
Yes, ma'am. Because if there is flexibility, say today, suppose I am busy from 6 to 8, so I
Mm-hmm.
will plan that in 3 to 5. That is the
Yeah,
flexibility we have.
correct, correct. Yes, you do.
So anyone from the others, okay, anyone has attended today's session or it was not there? Anyone from the audience?
You may raise your hand if you have attended the other session.
Excuse me, ma'am.
I
Yes.
I tried to open that link, but it was rejected, so it wasn't there, I think.
Okay.
today
So Anupam, I
today
think what you are saying is right. Yeah.
okay, ma'am. Thank you, ma'am.
Okay. All right. So let's get started. So in this week, um, the topics that are covered are motivational examples and compute platforms for cyber physical system. So technically, I would start with some of the questions in the practice assignment that has been given. And I would also try to go through some of the questions in the week one assignment. And later, if you have any doubt in any of the topics, please feel free to tell me, because I have the PDF also here of the um, no, a lecture that has been covered by the professor. So we can reiterate over that as well.
Ma'am, if you don't mind, can you just flash these PDF so that we can? So I have seen all the what you say video lectures, but
Mm-hmm.
now I am okay missing something. So can we flash it first as a revise of first week? Then we will go to
Okay,
what you
you
say.
want it that way?
Yes, ma'am. So no, it is beneficial for all. If
Okay.
you
All right, then we can do that. Let's just revise that maybe for like half an hour, and then we'll go to the questions. Does that work for
yes, ma'am.
everyone? Okay. All right. So this is how it starts. Okay. So cyber physical system basically means that you have some kind of physical components, and they are somehow connected to each other. Okay. So there is always a communication part to a cyber physical system. And after that, even if they communicate, so what do they communicate and why do they communicate, right? So the first thing is, over here, let's say this is a physical system. Okay, so maybe it may be sensing something. Let's say it's a sensor or a temperature sensor or a humidity sensor in a farm, right? So it is trying to do something, it is trying to sense the thing. Now over here you might be having some kind of logic that is written so that you analyze your sensor data, right? So you always have a compute component as well. Okay, and now whatever you do based on the data collected, you maybe you can transfer the data to others, or maybe you can just transfer the data to some kind of a central entity, right? And based on whatever they decide, it comes back to you and it says that you need to do something else. Okay, so there is always an actuate part, but let's keep actuate in something called as a control part. Okay, so there is a control component, a compute component, and a communication component to a cyber physical system. So in general, this is the overview. All right. So over here, let's say you have this plant, as I said, right? So this plant is more like a power plant that is being talked about over here. And let's say they have multiple sensors. Okay. Let's say, like pressure sensor or things like that. And that sensor data is sent to some kind of a, it's sent over a network to some kind of a controller. Okay. So this is the controller. And then over here, you do some kind of a computation on that data that you have received. Okay, so now after that, you send that over the network again back to the plant. And then over here, some kind of actuation happens such that you try to change some kind of your some activities change that makes some change in the sensor data. So let's take an example over here, which will help you understand. So let's say you have a pressure sensor, and let's say this is a pressure sensor in the steam of the steam, right? So now let's say over here the pressure has been exceeding a lot. Okay, and then when you send that high pressure over here, you need to reduce the pressure, otherwise something bad is going to happen. So now over here they say that now you produce the steam at a lower rate compared to what it is being produced right now. Okay, so this action comes over here and then this actuates, so it slows down the speed of something that reduces your steam production maybe, and that finally reduces your pressure. So some kind of a control loop goes on. Okay, um, and some kind of computation also happens. So these are the basically things about your cyber physical system. So yeah, these are, so the first example that the professor takes in this is basically this HVAC, okay, which is this heating, ventilation, and air conditioning. Okay, so this is the HVAC system, and they do it for multiple buildings, like these intelligent buildings. So you build the control surfaces. Okay, so these are the different things, like you have this access control, you have CCTVs, you have fire detection, you have lift, you will have your HVAC, you have lighting, hydraulics. There are multiple things that are, incorporated when you actually want to construct a building, or like, like a big apartment, those kind of things. Okay, so the first thing that they talk about is building temperature control. So here they say that how do you ensure that a set of rooms are satisfying the user temperature requirements with suitable compute factor. Okay, so these are some of the questions that will always come when you are designing a cyber physical system. Okay, so this is the big system. I won't go into detail in this right now because we have to cover others. But let's take a look at this and understand this a little bit. So if you want to build this energy management problem, right? So first of all, the first thing to do in cyber physical system is to model your system. Okay. So you have modeled your system. So over here, what they say is you have to derive the underlying thermal model. And then based on that, you decide on a suitable control algorithm. Okay. And then once you have decided on the algorithm, you control the duct airflow and the vent opening. Okay, so now let's say over here you have your building. Okay, so that building is sending the data to the data repository. Okay, and let's say initially you have some kind of, like offline one step calibration, but then later you need to always recalibrate based on the new data that is always coming in. Okay, so this is your Kalman filter. All right, so it is sending some kind of states and parameters and all of that. That is going to some predictive model, predictive control. This is NPC, and that is going back to your building, which is trying to control your temperature or control your basically your energy. Okay, so other thing also is, do you send it to a controller? Okay, and there is another, like these are different things basically, like this is something that how you do you cater to dynamic situations. So these are more like disturbance estimators. So if those kind of things are also incorporated, like let's say it is winter or it is summer, so depending on that you kind of work on your energy. So there are multiple things that are going on over here, and that is what motivates your cyber physical system. Okay. um Yeah, one thing that was discussed over here, let's say again, right? So when you are doing this temperature control or any kind of control, right? Energy control. So if you have a wall that is made of a brick, the transfer through the wall is very different if you have a wall that is made of a glass, right? So the heat transfer over here is very different from the heat transfer over here. So the heat transfer through a wall is represented using this kind of a circuit, but the heat transfer that is through a glass window is represented through this kind of a circuit. So let's not go deep into this, but try and understand that if you have different kind of things, it actually changes. Okay. uh, okay, there is something going on with my, so it is visible, right? Okay, all right. Yeah, so for those it yeah, Shiva, you can, I think, rejoin, maybe try to rejoin. That is going to help you. Okay, it's not visible for many. It's for half an hour. So for whoever it's not visible, please try to rejoin. It might help. Yeah. So the first thing that they do is you have to simulate your building model. Okay. So simulation is the key step to do these things. Okay. And the very important question is, where will your computation take place? Okay. So that is very important. So now if it is CPS implementation, so like you have this physical component and your environment, and then you have the control algorithm, right? So but where do these control algorithm actually run? So these control algorithm are going to run on your embedded platform. Okay, and once your embedded platform that runs and it sends you some output, what is it going to affect? It's actually going to affect back to your physical component and environment, right? So this entire loop is basically your cyber physical system. So you have communication going on between components, you have a control algorithm running, and you have a compute system that's available for you. Okay. um
Ma'am, what is cyber in this? Cyber, whenever we say it means computation or communication or interlinking
it
of
means a
communication.
it means the, yeah, exactly, it means the intersection of both, I would say.
Of computation and computer. What you say?
Sorry.
Combination of control algorithm and embedded platform, wherein
No,
attacks
no,
can
no, 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 it is combination of compute and your communication. That's what is cyber, right? You need to have networks and you need to have your compute
whenever
power.
we say cyber attack, so it is cyber. Whenever we say attack, so that is only in the communication or in the computer. So it is both.
I think it's a very broad term. So even if your network is attacked, you always say a cyber attack, and even if your computer is attacked, you say it's a cyber attack, right?
So computer communication can we say is a cyber.
I'm not understanding your question. Could you repeat again?
Computer communication, if we say
Yeah.
in one.
So I'm saying that, yeah, something which is incorporating your compute or incorporating your communication, both of them can classify as a cyber thing. Okay. Okay. So let's see. Yeah. So over here, they have just talked about this HVAC optimal control. You can go through it later. But yeah, one more thing over here is, let's say most of the things you're trying to evaluate in the simulation. Okay, so how does your co-simulation fabric looks like? You will have multiple components. Okay, so first of all, you will need to have your simulation tools. Okay, that what is a controller for you, what is a computer, all those things. And then you need to have some kind of a network traffic simulation. So NS4 or Omnet++, that provides you that kind of a simulation. So in these things you can, like emulate your network. Like if you set that these two devices are going to have a bandwidth of this x mbps, that is going to happen over here. And then there are different energy simulation tools, and then you have the control algorithm which happens in the MATLAB. So this is what is being used probably by the professor, so he has suggested all these, but this is also generic and it can be used for different kinds of applications. All right, so yeah, these are fine. Let's see. I think let's go through this data driven control, because there is one question in the assignment based on this. So this is going to be important. So data driven control. Okay. So can one of you just take a guess as to what this means? Data driven control.
Ma'am, we have a past data. So from
Mm-hmm.
there, some mathematical tool will give the future, okay, control, what you say, points.
Correct.
That is
Correct.
that is the data.
Okay, good. Yeah. So data driven means it is driven by your data, and where is the data coming from? It is coming from your past readings, right? So if you have some kind of function, right? Will this class be uploaded as a video? Yes. So you have a function, then you have x1, x2 until like xm, which are basically the different features. Just give me one moment, please. Yes. So as we were discussing, so these are different features. Okay. So x1, x2, you have different features. So basically, how does your y parameter, like changes based on as a part of um, these different parameters. So you try and train a regression model, okay, based on these values, the data that you already have. And then for a future reading, you try and predict this value of y for the function that has been learned using your regression model. Okay. So this regression tree actually predicts the regions of variables that is controllable and observable. I think this is a very different concept, but you can also go through that. And then we have the leaf level, which is the linear models link up objectives with control variables. So let's go through this itself. Okay, so this X is probably the more important part, because you need to understand what variables are changing your final output, right? So these are the different variables. And there is this tree learned only on non-manipulated variables or features. So there are these disturbances, okay, and then you have regression on manipulated variables. So there are these two parts to it. Okay, so in general, regression means if you have this kind of a equation, let's say y is equal to this constant beta naught plus beta 1 into x plus beta 2 into x2, right? So you actually learned beta naught, beta 1 and beta 2 based on the past data that you have for x1 and x2. And then for future, you are going to have an equation like x naught is equal to, let's say, 50 plus 51x plus 52x2. And this is going to be your I. So for future, whenever you have a new x1 and a new x2, you will be substituting those values in this equation. Okay, so that's what is generally there. Yeah, CPS of connected vehicle is one more important thing nowadays, that autonomous vehicles are for real. Um, So let's say we have these autonomous vehicles, then we have number one a software implementation for each of these vehicles that are there, and then you have a hardware architecture to each of them as well. Okay, so yeah, so in the software you need to have the feature mapping, timing analysis, like so that you um, have these real time performances, and then you need to have your architecture ready so that you can process those things in real time. All right, so again, modeling is very important. You need to model your things, or model your entities basically. So for intelligent transportation, it is mostly like you do the network modeling because networking is important. And then you need to have the systems model, that is the autonomous vehicle model, which is the onboard intelligence. So you need to have the computes also modeled. And then there is this highway traffic modeling. So this is basically learning from your data and trying to predict the traffic. Okay, these are fine. I think you can go through these. There was one important thing that I wanted to discuss. Yeah. So this is autonomy in platoon control. So what is a platoon, right? So this platoon can be viewed as a string with time varying spaces. Okay, so these are basically, let's say you have one vehicle, two vehicle, three vehicle, and the fourth vehicle, right? So over here, this says that the driver in the first container is leading the three driverless trucks. Okay, so these three are driverless, and this is the only one that has a driver. And these trucks basically they incorporate vehicle detection, anti-collision, and lateral control technologies for safety. Okay, so these are the different things that are incorporated in these driverless um, trucks. Then we have this coupling and decoupling to allow other road users to cross between platoon vehicles. So this set is the platoon, right? But it's not always necessary that there may not be some space between these. Correct? So they need to provide space to other vehicles so that they can overtake them and they can also continue their journeys, right? And the lead vehicle linked to the platoon via the wireless communication. So this is the wireless communication using which these are connected, right? So one important criteria for this platoon control is that the string needs to be stable. Okay, so the spacing which is there, it needs to be maintained constantly and it cannot change arbitrarily. Okay, and if there is a braking action by this vehicle which is leading the rest of the three, it is instantaneously communicated to all through the nodes such that all of them brake at the same intensity. Okay, so basically how is this like happening actually? So ANNs are being used for this. All right, so this is the platoon control. I think there is one question based on this as well. Again, so in the case of autonomous driving, you have a lot of implementation issues, right? So first of all, you have a bunch of components that you need to run on board the device. And if at all it's not possible, you need to find mechanisms how to offload it to some remote server for getting the computation back in time, right? So other than that, there are also this thermal constraint as to how are you going to cool these high-end computers in a car. And then you have the power constraint, which means that these GPUs that are inside the car, if they are going to consume your power, then the the power that your car should have gotten, that reduces, right? So that reduces your driving range. And the very important thing is that while you are collecting your data, and with autonomous driving in picture, you also collect a lot of images data, right? And images consume a lot of space. So the storage constraints are also there. And plus, even if these images are there, that is fine. There are terabytes of map information, right? So this GPS is not precise enough, so they need other kind of precisions, and you need to have different mechanisms for autonomous driving. And this is basically the thing. So you need to have a very good compute that gives you responses in real time. You need to make sure that the compute gets proper physical coolness, or it gets the proper power. and you are also able to store the data properly. Okay, so there was one part where it was discussed about the small scale automotive CPS. So yeah, so small scale means you have some kind of a robot, right? So in general, if you want to do that, you need to have this Jetson Nano Developer Board is nothing but your compute. Does anybody know about this?
Um,
Okay, so I would suggest you to read about this when you go back. So read about NVIDIA Jetson devices. Okay, these are basically, I would say, state of the art that's going on right now. And you should know these when you are actually studying about cyber physical systems. So these are those devices that have a CPU on board, plus you have a GPU on board also, right? For autonomous vehicles, what do you need? You need some kind of image processing, right? That is the very basic image processing or computer vision, correct? So in the case of computer vision, if you want to process a lot of images in very like I would say in a very efficient manner or in a very accurate manner, you need to use these DNN models. Okay, so can anybody name any one DNN model that is used for image processing or maybe object detection? Take a guess, that's okay. Yes,
CNN,
yes, CNN is fine. CNN is used for what?
image processing.
Okay, specifically like detection or classifications, right? That you do.
Yes, ma'am, identifying objects.
Correct, yes. So you have this. So majorly, if you want, you all can look at this YOLO also. So to run these kind of DNN models, you need a GPU. That is a graphics processing unit, right? So in that case, yes, SSD is another model. That is correct. So SSD is also there. Okay. So these GPUs you need
What is
because
SSD?
these SSD is a type of model again. Like you have these CNNs, right? So those are another kind of models. Those are also used for detection only, as far as I guess. So if you want to run one DNN model on a CPU, let's say if that is taking you 10 seconds, and if you run it on a GPU, that may take you, like 1 second, depending on how powerful your GPU is, because it does a lot of parallel processing that the images require, right? So these NVIDIA Jetson devices actually have a CPU on board and a GPU on board also, and they are actually very powerful, even though they are just very small, you know, like the size of a Raspberry Pi. How many of you have heard about Raspberry Pi? Please raise your hand. Nice. So two of you have heard. Those of you who haven't, please go back and check that because that's going to be very, very important for this course. Okay. So Raspberry Pi is something which is called as an edge device because you're trying to run the compute right where your sensor is. Okay. And NVIDIA Jetson devices is similar. It's just that it has an onboard GPU. So these just have a CPU on board, but you can still attach an external TPU also to make sure that you get these DNN processing done on Raspberry Pi. But over here, you have a GPU on board that helps you get the DNN model. So these two are kind of a similar sizes. It's just that the performances are much better. Okay, so I would suggest you to go through these. So the very old version of NVIDIA Jetson devices is the Nano. I wouldn't say very old, but it's more like something that has been outdated, and um, it cannot run very heavy models. It is just for, like lightweight purposes. And then you have these new ones that is called as AGX or this um, you have this Xavier NX. So there are multiple other things. Okay. So there are multiple kinds of these NVIDIA Jetson devices. You should take a look at that. Let me just share this on the chat window so that all of you can check it. Yeah. So I've shared the link. Please save it because probably after you leave the chat, after the session, you may not have access to the chat window. Okay, so you can save this link somewhere. Yes, the PPT would be accessible. Yeah, I will make sure that the notes are there. Okay, so any more questions in this concept that I have just told? Okay, great. So let's move on. So yeah, in general, you have these different components on a very small kind of autonomous vehicle system. So this is how a Jetson Nano looks like. And the other version of NVIDIA Jetson series will also look very similar. It's just that it will just get a little bigger if you move on to the high-end GPUs. Okay. These are fine. Yeah, another important thing is this robot operating system. So ROS is basically an open source and a meta operating system that is used for robotics application. And it basically has these different features such as hardware abstraction, low level device control. It has message passing between the processes. You have packet management and you have various tools and libraries for developing the code. So since this is open source, this is a very important thing that you could learn if you are interested in this kind of a domain. Okay, and it actually doesn't matter where you want to run your code. You can run it in simulation or you can run it on hardware. ROS is adaptable to both of them. Okay, I will forward the link for that also so that you have the actual documentation. Yes, please go through this link also so that it will help you. Okay, another thing that is important is this SLAM. So SLAM is more like a technique that helps you in autonomous navigation, and many researchers have used this. Okay, so this is a technique of constructing or updating a map of an unknown environment while simultaneously keeping track of an agent's location. Okay, so while you are moving in some kind of a map, you are trying to construct a map as and when you are moving, right? So this is what happens in SLAM. Yeah, these are different examples as to what is there? Um, Another thing about this real time simulation, and I think we can close it over here. So this one's very important. So let's say you have some inputs to your from your sensor, right? And then you want to run your model on top of it, and you are getting some output after that. So if you are doing that in some time steps, let's say in a time step of 50 microsecond, that is, let's say your interval of calculating your data that has been read from the sensor, right? So if at all there is some kind of input for which you predetermine that the time step is gonna be 40 microsecond, okay, but it could not finish the computation before 40 microseconds, and the outputs generating the outputs was overrun into the next time step, then in that case what happens is that that is called as an overrun. And once an overrun occurs, then you always shift to the new time step and then only you calculate. So it's not going to happen that you are going to take the inputs from here and then you're going to do the calculation. Okay, so this is what is the overrun concept over here. But yeah, it's just that the data is not being lost. It's more about the interval at which you are calculating your data. Okay, I think this is mostly it, because later it's more about the detailed explanation about each of these simulation and things like that. So any questions about the high level concept covered till here? We can spend about 5 to 10 minutes here, so you have time.
And means now say suppose my step size is 50 microsecond, the
Mm-hmm.
computation should happen before that. Then it is not overrun. Now if computation is not happening at 50 microsecond, then it is overrun.
Exactly, because over here it is just showing that initially it was 50, right? So it was completing by then. This example is to show you that if you reduce your TS to 40, and in that case the outputs are still not calculated, then it creates an overrun. So you need to, tune your step size properly. That is the motivation towards these slides, because you see that this has changed. Over here it's 50.
That means my calculation is happening before 50, so I can tune that to the 40.
No, since you are getting an overrun at 40, you should tune it to 50, so that computation of one time step doesn't overrun into the other. So this is what is the thing. Otherwise you are going to lose this much amount of time, right?
Okay, okay. Thank you, ma'am.
Mhm. Any other question? So should we get started with the assignments now?
Yes, ma'am.
Okay, great. So yeah, I okay, before I start, how many of you have actually solved assignment 0? Okay, one of you. Okay, that's fine. So please go through the assignment. That is going to it's more like a fresher assignment, so it will just make you revise the concepts that you have already known. Okay, Anupam has also solved. That's nice. So there are basic questions over here. So the first one is find the determinant of this matrix. So if you have this, right, 2 minus 3 1 3 1 3 minus 5 2 and minus 4, right? So how do you calculate the determinant of this? So 2 into, you have minus 4 minus 6 minus of minus 3. Solve with MATLAB. Very nice. Yeah, that's good. So you have already MATLAB, you have already set up MATLAB. You have to solve with MATLAB. I think that is for assignment. That's probably this part that you're talking about. I'm not sure. This one, right? You're talking about this.
Yes, yes, ma'am.
Okay, okay, cool. Okay, that is fine. So what is the answer that you got in this question? Zero. Nice. Okay, so if anybody wants a solution, they can refer this. Okay, a similar question, find the inverse of A. I would not solve this. I think this also follows the same procedure. You can also use MATLAB. So anybody wants to tell me the answer to this? What is the first element? Okay, before we do that, can somebody tell me what is the determinant of A?
The first element is 1, second
Mm-hmm.
element 1, third element is also 1, first row.
Mm-hmm. Mm-hmm.
Second is 3 by 10, 7 by 10, 3 by 5.
3 by 5 is okay.
Then minus 1.1,
Mm-hmm.
minus 0.9,
Mm-hmm.
minus 6 by 5.
Okay. And what is the determinant of this? If you can quickly calculate and tell me.
Ma'am, I have calculated this by online inverse.
That
So,
is
but
okay. You can do that online inverse, but you can also do the determinant also, right? Online
okay,
only. Yeah. So just quickly calculate and tell me.
Minus 10.
Minus 10. Nice. So the reason why I asked you to calculate the determinant of A is because only if your determinant of A is non-zero, only then you can calculate an inverse of a matrix. Okay, that's how we do that. Okay, moving on to the next question. This says time constant of an RC circuit is given as tau is equal to RC. What should be the voltage across the capacitor at 100 seconds for the given circuit if the voltage along the capacitor changes following this? Okay, let's see.
so ma'am, in this RC, first we calculate. So R
Mm-hmm. Okay.
is tau. Now this minus 5, this is 0.
So this is 470, right?
4, I'm getting 47.
47 kilo ohm and 1000 microfarad. Okay, yeah, sorry. It's going to be 47 seconds. Okay. So now what should I do after this? What is your VC0? What is VC0 over here?
5 volt.
5 volt,
It
correct?
is
It is what?
5 volt.
Correct.
Then 1
So,
minus e to the power minus 100 by 47.
correct. So this becomes how much? Right? 4.4 volt is the voltage remaining at your source after 100 seconds. All right. So again, let's go to the next question. So we have find the eigenvalues of this particular matrix. So how do you calculate the eigenvalues now?
So we have to calculate A minus lambda I, and then that we have to find determinant of that
Okay, and then what do we do?
is equal to 0. Then we have to find the roots.
Correct. So what is the equation that you get? Can you tell me that? If you remember, or else I'll just solve it. This is correct, right?
Yes, ma'am.
Okay, so you're gonna have this 1 minus lambda into 2 minus lambda into minus 1 minus lambda plus 1 minus 3 lambda plus 2 plus 4 into minus 1 minus of 2 minus lambda minus 1 minus lambda, right? So this you have to equate to 0. Okay, so finally it is going to come like this: 2 lambda square minus 5 lambda plus 6 is equal to 0. So you will have lambda minus 1, lambda plus 2, and lambda minus 3 is equal to 0. So what are the options you have? 1, minus 2, and 3, which is your D. Is that correct? And everybody has gotten this answer?
Yes, sir.
Okay, good. Alright, so the next question is find the Laplace transform of this function. So this function is split into 4 times, I guess. So it is 0 if your time is between 0 to 1. Okay, it is t for this time of 1 to 2, and then if your time is greater than 2, it is again 0. It is right. So you are having this Laplace transformation of your function. So in general, you take from 0 to infinity of your ft into e of minus st into dt, right? But eventually what is going to happen? If you take from 0 to 1, that will be 0, and 0 to 2, I mean 2 to infinity is going to be 0. So we'll just consider for the one part, that is t. Okay, so t into e of minus st into dt from 1 to 2, right?
If we solve this, then D is the answer, ma'am.
Okay. Okay, I think you have already solved it. So all right, so if anybody wants me to solve this, just raise your hand please. I'll continue, or else we can just mark D as the answer and move on.
Yes, ma'am. Ma'am, can you please tell about Laplace transform? Like, how much would it be needed in the course?
Um, I am not very sure how much it will be needed in the future, but this is a very important concept in controls. So if you have this knowledge of Laplace transform, that would be good,
Okay.
because I think maybe at least 2 weeks it will go on for control. So probably it will be required. But it's always good to know about Laplace transform.
Engineer
Thank
lab.
you.
And it's there is Laplace and there is Fourier also. So go through both of them.
Thank you.
All right, so there is this inverse Laplace transformation now. So one trick that you could use is s plus 2 by this entire thing, okay? And four s plus 13. And what is this translating to? This is s plus 2 the whole square plus 3 the whole square, s plus 2 the whole square plus 3 the whole square. Okay, so eventually it becomes, so if you take the inverse of this, it becomes e minus 2t cos of 3t plus e to the power minus 2t sine of 3t by 3. Okay, so I think the first one is the correct answer. Okay, now comes a, I think this is some kind of coding exercise which will help you um, code in MATLAB probably. Yeah, I think it is. So let's understand this. If you have one matrix which is A, the dimension of which is n cross m, and if you want to multiply it with another matrix B, which is P m cross P, so if you have the product as C, what is going to be the dimension of that?
N cross P.
N cross P, right? So over here, it asks the resultant matrix dimension. So it is going to be N and P, right? And if you want to initialize your that final matrix, which is your C, your iterators should have N first and then P first, P then after that, right? And now after that, if you, yeah, so this is iterating over A and B and storing it in the result, right? How can it be M, I, and K? Okay. So M multiplies and then you have your, there is something wrong with the option, maybe. Or 1, 2, 3, 4, 5, 6, 7, 8, 9. So NP is only for 2. Okay, there are more. Fine. So this one initially starts with N. Okay. This one will go to P. And then your K is actually going to be what is over here. Right. So this becomes your P. So finally, A of IK and B is going to be of KJ. Right. So that is how it's going to be how the multiplication is going to be. Okay, so this is probably your correct answer. Okay, so now there is this physics question. Let's see what this says. You have a ball over here, right? And that is being released from a certain height. So initially your height is basically this 10 meter. Okay, so your h of 0 is equal to 10 meter and your v of 0 is equal to 0 meter per second. All right, so it is released from rest. and time is equal to 0. That's what it is written. So your v of t and your h of t is at what time this is your velocity and at what time this is your height. Okay, so when the ball touches the ground, it loses 20% of its actual speed. So once it comes over here, the velocity with which it goes back is 20% of the velocity by which it hit the ground. Okay, so when the ball is bouncing down, its velocity is calculated using this. And when the ball is bouncing up, its velocity is calculated using this. All right. So there is this following C function that is simulating the bouncing ball scenario until the height that the ball reaches after the bounce becomes less than 1 meter. So there will be multiple bouncing, right? And at some point it is going to become less than 1 meter. So if t is the required time, if it is the time required for an object to reach a distance h starting from a velocity v, then this is the height where f is the acceleration on the object. So now this is asking complete the blank from the following options. So you are asked to finish this code. Okay, so let's see what this says. It says float of u is equal to 0, obviously, because over here this u is 0. And then you have v, which you have to calculate. So your v is actually going to be u plus g, is it?
GT.
Mm, 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 mm. Yeah, I think they should have mentioned this g over here because the units are different. So again over here also the same thing. It should be g into t. All right, let's see. So now g is given and t is given. Okay, so I plus plus time to drop from height h. So what is your t going to be? So it needs to know the traveling time from here till here. Okay, and then the velocity after drop is going to be how much? 20% lesser of the actual speed. So which means that it is going to be 80% of what it originally was. Then u is equal to 0. So velocity after the ball goes up. Okay. And then t time to go up until the velocity becomes 0 again. Okay. Height up to which ball will go up. All right. So has anybody solved this or do you want me to solve this right now?
So T ma'am, T will start from 10 9.8 because 10 is the height. The initial velocity is 0.
Yes.
So initial T is 10 by 9.8.
Mm, no, it won't be like that, right? Because you have this governing equation that the distance that you cover s is equal to u square minus 2gh. S square is equal to u square minus 2gh. Minus or plus? I guess it's plus because it's coming down, right? So the acceleration is helping it, right? So that's how this is the third gravitational equation, if I'm not wrong. No, sorry, kinematic equation, right? So the distance, so basically, if you want to cover this distance of h, so over here it will be h square is equal to u square, which is your initial velocity, which is 0, plus 2g into h, and your h is actually going to be the 10 meter that you are saying.
It is T is equal is square root of 20 by 9.8.
How would you say that? 20, have you calculated?
See ma'am, yeah, S is equal to half GT square, na? So because initial is 0, so now S is 10. So now G is 10 divided by 9.8. That is it is coming square root of 20 divided by 9.8.
Okay, just a second. So you are saying this itself, right? V square minus U square by 2G. Okay. Basically, you have to take out the time. You're saying this, right?
Yes, yes.
Hmm. And then V from here. So your V is how much? U square plus 2GH is equal to half G T square. Half G T square? No.
No, actually, he was saying second law of motion, h equal to ut plus half at square, where we know initial velocity is 0 u, h equal to half gt square.
Yeah, this is correct. It's not V is equal to. Yeah. So just a second. Let's see. So if your H is equal to this, your H is out of the picture over here.
Here,
Since your U is 0. Mm-hmm.
yes, this is right. 20 divided
But
by
your
9.
U is 0 only in the first iteration, right? Over here, your iteration is changing. So your U needs to be there, right? So over here, this is gonna come, right? This is correct. Or maybe GT square.
Yes, ma'am, you can
Mm-hmm.
find the time. Now you can just write like 2h by a equal to t
Mm-hmm.
square, and then it will come under root 2h by a equal to t. Then ma'am, you can multiply the numerator and denominator by root of g. Then g will come out of, so that we can fill the blank there. Now we can write once 2h under root 2h by g, and then multiply by root g both in numerator and denominator, so that g will come out. Yes, on 2h g upon, yes ma'am, upon g.
Right?
So yes ma'am, we know h equal to 10 and g equal to 9.8. So it will become 196. So root of that is 14. So in the blank it will become 14. 14 by g.
In which blank you are saying?
First blank. T
But
is equal
yeah,
to,
yeah, this is fine. I'm not saying about this. I'm saying that you need to come up with an equation. This 14 is correct only for the first drop, right? So
yes ma'am.
this equation says that you have to find all these for multiple iteration. Correct? Because for the first one it is 10. I agree. But when this bounces back, it will not reach it will not reach till 10 meters, right? It will reach, let's say, somewhere over here. Correct?
Yes
And
ma'am.
from there, if it is going to go down, then you have to calculate it again. So you need to kind of have a function which is calculating that for every iteration, not just for the first iteration. Do you understand what I'm saying?
Yes ma'am.
Hmm.
Yes.
Okay, so if you have this, your understanding is correct. That is totally fine. So if let's say we have this, okay, so let's not solve this with the values, but let's substitute this. So this you got from this equation only, correct? V is equal to root 2h by g, because you substituted u is equal to 0. Am I right?
Yes ma'am.
Okay.
Ma'am, we can do so. Like ma'am, we can calculate h in terms of we can take v is equal to 4 by 5 u. The it will v equal to 4 by 5. The velocity of when it drops, the velocity was u, right ma'am? So when it
Yes.
will go up, it will go with a velocity of 4 by 5 u, as per.
Yeah, that is correct. That I already filled over here. 80% I
Yes ma'am.
did. Yeah,
Yes ma'am.
that I did. Hmm.
So we can calculate the height h is equal to 4 h equal to u square by 2g. 4 by 5 u whole square by 2g.
This?
Now 4 by 5 u whole square by 2g. 4 by 5 u whole square by 2g. Yes, ma'am. So on this will be the variable height. We have an equation for height now. We can fill this in that
Yeah,
time
this
equation.
height is fine. They are asking for the time. So
Yes, ma'am. We
currently
can
they are
fill this height
calculating.
in that equation of
Mhm.
time that we have found.
The one over here you are saying.
Right side, below, bottom right.
Over here?
Yes, ma'am.
Hmm.
Yes, ma'am.
But this is for which height? The height to which it goes back?
Ma'am, this equation will always be applicable whenever it drops
Yeah. So we have to calculate the time, correct?
to drop. Yes, ma'am. So, ma'am,
Hmm.
this would be a variable equation.
Can you say that again? Because over here I'm getting this actually, because if you have this velocity, right? Um and you divide it by g. So I'm just trying to check if like so if d is the time it takes for an object to reach a height with a velocity vt1. So can we calculate for one at a time? So which one are you talking about? This time or this time? The first one or the third one?
First one.
First one. Okay. So let me just copy paste this so that we have some space. Okay, we have some space over here. So now over here you have u is equal to 0, correct? And you have to travel something. And later you will have some u, and this is your height, right?
Yes, ma'am.
This is what we initially have, let's say. And you also have this equation, h is equal to ut plus half at square, right? So now what are you asking me to do? Tell me. So time to drop from height h, right? So your u is going to be 0. So this is what you have already solved.
Yes, ma'am.
Hmm. So you have 2h is equal, sorry, 2ut plus at square.
Yes, ma'am. But our u is 0.
Oh, you have to use 0, is it? But you, is it going
Yes,
to
ma'am.
be
In
0
the
always?
program also, they are declaring u equal to 0 in the
Right.
before calculating second time, they are putting u equal to 0 only because
Right. I think
again.
every time, because over there you are going to
Yes,
stop
ma'am.
and then you
Yes,
are
ma'am.
going to roll back. That is correct then. Cool. So this is going to be 0 for you. So you are actually having 2h by g under root, that is going to be your time.
Yes, ma'am.
So, okay, so you were saying that your now I understood why you were saying about this. Okay. So 2gh by g. This is what you were saying.
Yes, ma'am.
So your answer over here should be 2gh, right?
Yes, ma'am.
Okay, got it. Now I understood. Thanks for doing that. All right. Now let's go to the third one. So it says, okay, so now we said that velocity after drop is going to be 80% of what it reached. And now it is what? Time to go up until the velocity becomes 0. So v is equal to u plus at. So over here time is v minus u by g. So this is going to be v minus u. And so your final velocity is going to be how much? 0, right? But your g is actually opposite, so it should be minus g. Let's see. U plus at v minus u by g. But if this is your 0, because finally you're reaching there, and your u is also in the opposite direction, and g is also there, so it is going to be u by g, if I'm not wrong. Is this
Yes,
fine?
ma'am.
Okay.
Yes, ma'am.
So over here it will be u. Is that right? Okay, so I
On some
think
other variable, v. U is 0. We will take v here. Ma'am, in the program we will take v.
got it. Okay, because you're actually calculating the wrong. I understood. Fine. Okay, so I think this is good. Let's go to the this week's assignment questions. So I think the first one you should be able to do it on your own. What is the second question? It says if all eigenvalues of a matrix A have norm strictly less than 1, the spectral radius is less than. I think this is coming from the matrix theory. So any of you were able to solve this, or do you want me to explain this one? I think this one is supposed to be done in MATLAB, right? And they have provided the explanation for that. Let me check. They haven't.
Question. Second
The
question is
second
the
question.
the concept of this matrix, special matrix called as Schuller stable matrix, so in which I are less than one. So I think this we have to learn. So that,
Okay.
in my opinion, the answer is C, ma'am.
No, no, you don't have to say the answer because everybody has to solve the question, right? So that is fine. Okay. So let me see if I can come up with some kind of a tutorial on this in the next session, because definitely the assignment due is when? Can one of you tell me?
Due is in February.
Yeah, February what? Like, will my next session come before that? 5 Feb, right? And we'll have our next session on 1st of Feb. Yeah, so this is good. We can have a tutorial on this on MATLAB next week. Okay, about the spectral radius of A. So we'll do that. Okay, and even though you were saying, so yeah, Anupam, you were saying that you need tutorial for the MATLAB thing. So they have already provided this. Does this help you, or do you want like more information?
My question, I have only tab presently, so
Okay.
that changing for me. In case,
So does this not work on your tab?
no, ma'am, I have not tried online, but I once tried. I'm
Okay,
not able.
okay. One more thing. If you have this institute access, so try to access using your institute Wi-Fi, if that allows. I'm not sure if that may be the problem.
I'm working professional. So no
Oh,
problem.
okay. Okay,
We'll
okay.
this
Okay, then let me see if we can do something about this.
problem. But for a working professional, it is difficult.
Right. Yeah. All right. So the next question is about, again, these are more of theoretical questions. So you can think about this, refer to your notes, and then answer this properly. So the detectors are basically, I would say, sensors. Okay. So detectors in a cyber physical system, they are usually used in order to detect if there is a requirement for better cost optimization in control strategy. So see if they have to detect only if there is a requirement, or um, they can detect even if there is no requirement as such. This detector can actually be a little different than sensor because it may have some logic of if and else. But yeah, you can check this part. Okay, so now is high performance GPUs are used for autonomous driving. So I was talking about the GPUs, right? So this will come over there. So this can significantly reduce the vehicle's driving range due to high power consumption. So we actually went in the slides about this. So I think you should be able to answer this also. In data-driven predictive control using regression trees, the regions of controllable variables are predicted. So there were two kinds of predictions, right? If you would remember. So go through that slide again and see if what is the best answer to this. The next is using Sumo as a network simulator. With a mobility simulator like Omnet++, we can simulate a vehicle platoon. So vehicle platoon also, I went through that slide. So this is one part. One thing is Sumo was not covered in the lecture and Omnet++ was covered. So see what is this and what is this and what are they talking about in the sentence. Okay. So make sure that if they are saying that Sumo as a network simulator is a correct statement or not, Omnet as a mobility simulator is a correct statement or not. Okay, so you have to verify that and then you go with the answer. Okay, now the next question says robot operating system can manage low level device control in a lab scale autonomous vehicle setup. I think this is also an easy question. Again, the overrun. So basically, whatever questions are being asked, we have covered that in the slide. So an overrun occurs in a real-time system when the step size TS is too large, causing the system to skip computation for certain timestamp. So you have to check if this part is correct or not, if it is too large or is it too small. Okay. So the next question is, again, you have to do this computation in MATLAB. So you can check what is a stir stable. I think there is some condition about this. Let me just check.
Use one.
Mm-hmm.
Eigenvalues less than one is a condition.
Okay. So first of all, you have to check if it is a square matrix, which I think all of the matrices over here are. You have to check if they have real entries, which again that satisfies. And the third criteria that you said just now. So eigenvalues and the absolute value of eigenvalues. Okay, so that is very important. That should be less than 1. Okay. So this is the case. Again, this particular equation is a second order ODE as follows. Okay. So the following code evaluates this particular equation with mu is equal to 1 and initial value these. So I think you will have to fill the equation based on that exercises we have done till now. The next one is find out which of the matrices below are orthogonal, symmetric, and skew symmetric. And they have given the definition also. So I don't think you need to use MATLAB also. Maybe you can just check which one is symmetric or not. Mm, yeah. So you can check if it is symmetric or skew symmetric depending on this condition that A is equal to A transform or A, sorry. Actually, A is equal to A transform is for symmetric. Yeah, it's here. And A transform is equal to minus A. So you can just check that right over here when you calculate. And A into A transpose is identity. So you can check that also. I think this should be easy. The next question says, what is the command to find the determinant of the inverse of the cofactor of A? So again, so you should check that it is going from right to left, everything that it has said. Okay. Yeah, max function is used to find what and ABS is used to find what. So this is also fine. Yeah, I think this should be a good assignment for you and all of you should be able to score more than 90% and I would say aim 100%. Okay. So that should be good. The only thing that is left from my end is have a tutorial on this in the next class. Yeah. Any questions in the current assignment that you want help with and I did not cover?
12th question, what you said? We have to go from right to left.
What?
12th question, you said we have to go from right to left.
Yeah, basically you have to check if the operations that this question is asking is in the correct order. So you have to, you can
Cofactor,
go left to right also, that is fine, but you have to check that determinant is outside inverse, inverse is outside this and similar. Okay.
cofactor of
So you
matrix A.
always have to check that first of all you have A, right? So you take out the cofactor matrix of A. So that should be an input to this, the
No,
output of this.
my question is, what is the command for cofactor of matrix A? Inverse, I know inverse of A. Determinant, cofactor of matrix A, what is the command?
Hmm, it is the transpose of something, right? It is transpose of this. How do you calculate the cofactor? So it is if you have this determinant of A, right? Actually, the options are wrong, I think.
No such command in which we calculate cofactor of A.
No, there is no command as such, but you had to decompose one of these options such that it calculates your cofactor. That was the ask. No, there is no command, I think, in MATLAB to calculate the cofactor. So, okay, in MATLAB, they say that it is calculated like this. I can share this link with you. You can follow that. Blueprint or question pattern of the final exam. I think that you should check with NPTEL because we aren't aware of that. And if you have access, maybe you can check from last year question, but I'm not very sure.
So
This
what
is
is
how they provide.
question, ma'am? I think
Yeah, I
what is
answered your question here. Can you check the chat window? So they have
yes,
done it the other way because eventually, how do you get the um, determinant of a matrix? You have the cofactor which you divide by, sorry, you you take the inverse of the cofactor. Mm, not the inverse, the transpose of the cofactor. Cofactor of A transpose divided by determinant of A, right? So this is how they have done this. Okay. Is this formula clear as to how they got that part?
is cofactor of transpose of A. Cofactor of cofactor of transpose A matrix divided by A
No. You actually take out the cofactors and then you do a transpose of that, right? To calculate the inverse. It's not A transpose cofactor, it's cofactor of A and then transpose on that.
no in A B C D. If you see, there is
Mm-hmm.
no matching with this.
I see one of the answers there. So, and actually, this cofactor is called as this adjoint of A. There is an option. I think if you look closely, you will be able to find it. Any other question?
Thirteenth, ma'am, what is
Sorry, can you repeat?
now in this 13th
Mm-hmm.
question, are they taking matrix or they are taking any number?
They are taking both because this is a multiple choice answer. You can select more than one.
So my maximum of row in a matrix and maximum of column in a matrix, the command is same.
Yeah, so whatever you think is the correct option, just tick all of them because you can select multiple options here.
I think all are correct in this. The session is still there or is it ended, ma'am?
Yeah, I think we can formally close it. So I was just waiting for anybody to ask questions. But yeah, if anyone does not have any questions, please feel free to drop off. Thanks for attending. We will meet next Saturday, same time, 6 p.m. But if you have any questions and you want to stay back, you can do that as well. Thank you so much.
Thank you.
Thank you.